Following on from our previous video, we got to this stage here where the volume is approximately this thing here. And in the previous video, I asked you to imagine this as being delta A, as in this area here. But really, when you look at this, what's actually happening is that you've got a summation, nested inside another summation. So when you read this, you should actually read it like this. So what's happening here is that, as I said, this summation here is really a counting mechanism for you to scan through all your areas. So the origin is here, but we are going to start counting from here. So when j equals 1, so remember this is like this here. When j equals 1, so hang on, this location here is y1, this location here is y2, this location is y3, this location here is x1, this location here is x2, this location here is x3, and so on. So when j equals 1, when j equals 1, everything in here, j will be 1. So you're looking at j1 here, you're looking at this line here. So when j is 1, everything else in here will be, j will be 1. So for the first one, I1 j1 would be right here, and then this gets incremented to 2, so that would be right here, and then it gets incremented again to 3, that would be here, 4, it will be here, up to m is 5, up to 5, so up to 5, so you stop here, and then j gets incremented by 1, j gets incremented by 1, so really you're looking at this line here. So thereafter, here j equals 2, thereafter all the j's in here will be 2. So for I1 it would be here, I2 would be here, I3, I4, up to m is 5, up to 5. And then j gets incremented again by 1, so j equals 3. So now you're looking at this line here. When I is 1, it will be here, gets incremented again, and so on. So you can see this is just really, this summation here is really a counting mechanism for you to scan through all your areas. Okay, so just bear in mind that this thing here, subscript here, is just a location. It's just a location. So now hang on. So looking at this here, back to single calculus. When you have a height, which is f of x, the height, and then you have this dx here, it introduces another dimension. So this is a height, and then you times it by dx, it will give you an area. So from here, it will give you, merging with this, it will give you an area. So this is, remember, this is just a location. When you put the location, so say you're currently here, when you, so this dot here is really your location. So this thing here at the moment is just a location. When you put that location into the function, so when you put this location into the function, it will jump to the surface. It will jump to the surface right here. So now remember, this thing here is just the location. The location's right here. Put it into the function, and then this whole thing here will be the height. It will jump to the surface. So this thing here would be the height. It would be this line here. Okay, and when you read this, hang on, when you have a height and then you merge it with this dx, just like up here, when you have a height, merge it with the dx, it then gives you the area. So what this thing here is doing, it's from the location you put into the function, it would jump to the height, and then you merge it with this dx, so it will give you like a sheet of paper. It will give you this, hang on, it will give you this sheet of paper here, hang on, I can't, hang on, bear with me. It will give you this sheet of paper here, this strip of paper. And then for the next location, it will be here, jump to the function, and then it will jump to the surface, and then you merge it with this, it will give you another strip of paper. So eventually you're going to get, I don't know, eventually you're going to get a sheet of paper. And then later on, when you merge it with this, it's going to give you another, it's going to drag it in this direction. So eventually it will trace out the whole volume. So hang on, looking at this thing here, it will just bear in mind that this thing here is counting like this. It's moving in the x direction. So this is in the x direction. So this first summation here is moving like this. It's moving in the x direction. It's moving in the x direction like this. It's moving in the x direction. So what this is doing is giving you the area of a sheet of paper. So you can imagine this as being the area of a sheet of paper. So that's this area here. And then, so this thing here is like a sheet of paper. No matter where you are in the y location, y2 here, it will give you the area of the second sheet of paper. When y is 3 here, it will give you the area of the third sheet of paper, and so on. So when you merge it with this thing here, if you sum up all the sheets of paper, all the sheets together, it will give you the volume. I hope you can follow that. Hang on. So when m and n heads towards infinity, meaning each strip gets thinner and thinner, it will eventually become the true volume. So this is just an approximation. Take the limit, and then it will give you the whole volume here. Okay. I hope you can follow that.